morning, everybody. I'm Dr. Alberto Nembruni, authorized technical representative for Peroxicam in Italy. On behalf of the entire company, today I would like to present the remediation activity of a dichlorpropane contaminated aquifer in Italy using a microscale ZVI and organic carbon amendment. Before jumping into the case studies, just a few words on Peroxicam. Peroxicam is a global leader in soil and groundwater remediation technologies. We support clients seeing all projects through from the start to finish with a dedicated field support staff to develop remedial design and solutions that are efficient, cost-effective, and environmental sound. In particular, our tech group environmental tech group is mainly composed by 20 professional and 7 PhD scientists. Additionally, Peroxicam has laboratories focused on treatability studies and research. About the Peroxicam remediation technologies, we can summarize the remediation technologies in 4 main categories: technologies for in situ chemical oxidation, technologies for in situ chemical reduction, technologies for bioremediation and enhanced reductive dechlorination, and technologies for immobilization and stabilization. In particular, today we focus on the EHC technologies for treating chlorinated solvent contaminated groundwater using a chemical reduction approach along with a bioremediation one. The technology, the product, is delivered as a dry power on site and is mainly composed by a 40% of microscale zero valent iron, about 60% of a control release food grade complex carbon, plus micronutrients and binding agent. In particular, the technology is a sustainable solution since the product that composes the reagent is mainly composed by recycled raw materials. In particular, the ZVI comes from scrap iron from the steel industry and the complex carbon from the agriculture and food industries. Once injected into the ground, the EHC technologies start to generate 2 main degradation processes. The main one is a chemical one, and in particular is the beta elimination process. The second one is a biologic one, and is due to the fermentation of the carbon, releasing the hydrogen and so enhancing the dechlorination process. In particular, the combination of a biologic and a chemical approach allows to minimize and reduce the formation of byproducts, such as the DCE and vinyl chloride. About the degradation of dichlorpropane, in particular, EHC, once injected into the ground, starts to generate a combination of biotic and abiotic pathways, in particular the halogenation, beta elimination, and hydrogenation processes. In this slide, we can observe the 2 main anaerobic transformation processes of dichlorpropane, and both processes result in the formation of propane as a final step. Some characteristics of the reagent, we can see the molecular of the product is mainly composed, as I said, by ZVI and organic carbon. The ZVI, once injected into the ground, starts to oxidize, forming ferrous iron, releasing electrons, and the organic carbon starts to ferment anaerobically, releasing the hydrogen using the biologic process. So the combination of a chemical and the biologic process allow the generation of strong reducing condition with just 1 injection for a period up to 4 to 5 years from the injection. Some down gradient effect has also been observed that EHC can also sustain the treatment of plume or contaminated plume, since it has been observed the generation of strong reducing condition in the downstream zone from the treatment area. Application method, the technologies can be applied using the conventional methods such as direct push, hydraulic fracturing, pneumatic fracturing, can be placed as trench, as PRB, in a green mode directly into the excavation. But particularly, this slurry, the EHC slurry, can be applied using different concentrations, so to allow the injection in a wide range of permeability of the aquifer. In particular, we can see we can use a 35% slurry concentration, and this allows the injection in a very low permeability aquifer, such as the Italian case studies that we are going to see in the next slide. In particular, this site is located near Portogruaro, in the province of Venice, and in 2005, following a truck's accident along one of the main motorway in the north of Italy, we can see the motorway in green, about 3,000 liters of dichloropropane were released into the ground, causing an immediate contamination of shallow soil and the aquifer for more than 18,000 square meters. In particular, we can see in red the contaminated area. The primary contamination found at the site prior the treatment was mainly dichloropropane at concentration of above 10,000 micrograms per liter and 60 milligrams per kilogram in the shallow soil. Obviously, the local authorities required an urgent remediation action for both shallow soil and groundwater due to the high contamination level detected. Consultant performed a good characterization plan, detecting a treatment area up to 10,000 square meters, a thickness of treatment, a zone of treatment between 1 meter and 6 meters below ground level, so of about 5 meter thickness. Soil type, mostly silty clay, so a very low permeable aquifer where it's very difficult to inject common substrate. Local authorities fix site-specific cleanup goals of 0.16 microgram per liter in the point of compliance located at the boundary of the site. 3 main remediation actions have been performed. In a first phase, about 900 cubic meters of shallow soil were immediately excavated and disposed into the landfill, so to decontaminate the most contaminated soil. Second phase, the contaminated aquifer has been physically delimited using metal sheet pipe to a depth of 6 meters below the ground level, between 1 meter and 6 meters. In particular, in the picture, we can see the metal sheet pipe line in red. Phase 3, a total of 54,600 kilograms of EHC were injected under pressure into 42 injection wells. We can see the injection grid in green, between 1 meter and 6 meters below the ground level. In the meantime, during the EHC treatment, a surface recirculation system has also been maintained over the treatment period, so to enhance the diffusion of the amendment and so to enhance the generation of strong reducing condition. So, in particular, some details: remediation activity started in August 2012. About 1,300 kilograms of EHC has been injected per point. Product cost of approximately 1.5 euro per cubic meter of soil treat. In this slide, some details about the injection wells. We can see the screened part between 1 meter and 6 meters below ground level. Here a map of the treatment area, with in red the metal sheet pipe line, in green the injection point, and in red the monitoring wells, and in particular the point of compliance, PZ6 is the point of compliance. Results: after approximately 15 months from the injection, about 89% dichloropropane removal has been observed in all the monitoring wells located in the treatment area. And after 2 years from the injection, approximately 96% dichloropropane removal has been observed in all the monitoring wells in the treatment area. About the field parameter, all the monitoring wells have shown strong reducing condition, in particular high level of ferrous iron, low level of oxidant reduction potential, and low level of sulfate as indication of sulfate reducing condition were established in all the treatment area. Conclusion: EHC was successfully injected in a low permeability aquifer, high contaminated by with dichloropropane, using the conventional injection system. EHC is a green remedial solution generating low carbon footprint during application with few energy requirements and with minimal maintenance cost. Removal efficiency exceeding 96% of dichloropropane after 2 years, and in particular, we reach the cleanup goals in the point of compliance. Cleanup goals is 0.16 microgram per liter. Over 3 years following the injection, redox parameter, field parameter, suggested the reduction conditions were still established in all the treatment area, confirming the longevity of the product in the aquifer. Site closure was accomplished in 2015. Thank you for your attention. For more information, I'm available. Please come to join our group. Thank you.
So thank you, Alberto, for the presentation. I'd like to open the floor to questions.